Well, hello again. Welcome back to our swap notes. This week we're going to be going over soil texture, and this is a continuation of our hydric soils discussion. And the first thing we need to understand that soil texture relates to particle size, and that's essentially the beginning of it. And as you can see here, I've got a list of different soil types, sizes. We look at sand, silt, and clay as our three soil sizes. As you can see, sand, silt, and clay. Now, to give you kind of a relative scale on this, sand is about the size of a beach ball, and it's about the same shape, roughly. It's kind of globulose, generally speaking. Silt is about the size and shape of a frisbee. So we have frisbees to look at, and it's basically much smaller, but kind of more flat, and a little bit of concavity to them sometimes. And then finally, clay, which is the smallest particle, is about the size of a dime. And as you can see here, the dime, relatively small, relatively speaking. So we have sand, silt, and clay. And that is our rough approximation of texture. Now, why do we need to know texture? Well, texture is how the Army Corps of Engineers sorts the different hydric soil indicators that we'll be talking about soon. But we first need to know what textures we're in. And once we've got the textures, then we can start talking about some other features. Now, how do we get into textures in the field? We obviously can't look for beach balls, frisbees, and dimes. So we use a couple different methods. One is, and I'll pull this chart up, is the soil textural triangle. Now, this was developed by USDA primarily for agricultural purposes, actually entirely agricultural purposes. And as you can see at the top of the triangle, we basically have a lot of clay. Now, clay is not a great agricultural soil, so we're not going to spend a lot of time with clay from the standpoint of agriculture. However, in the wetlands business, we spend a lot of time with clay, so we're not going to focus too much on clay in terms of subdividing it if we're in the agricultural side. That's why the triangle doesn't deal mostly with that. For the most part, down here in this corner is a thing called silt loams. Many of our hydric soils tend to fall into the category of silt loams. A little bit of sand, a little bit of silt, a little bit of clay. And it's not an even mixture. It's mostly heavy on the silt. That's why it's called the silt loam. And that's the most common one that we find associated with basically mineral wetland soil types is the silt loams. But as you can see, as we kind of go across and down and around, you'll see the different angles that you can kind of form. So we've got sand, silt, and then clay kind of coming up and around. And that is a way of establishing, in a percentage basis, whether it's a loam, silt loam, clay loam. And if you notice, smack dab in the middle is a thing called loam. Now, loam is kind of an agricultural ideal, and it's not an even amount of sand, silt, and clay. As a matter of fact, once you get above about 30% clay, it's kind of game over for agriculture. It's just too dense. The water doesn't percolate into the soils well. The roots don't grow well. It's just too much clay. Very little can grow in anything that high in clay content. So we basically look at anything above that to be into the clay loam category, and then finally into clay. So many of our wetlands are associated with clay. A lot of times the clay is exposed deeper horizons. If you recall from our last discussion, we were into horizons. Well, the horizons we're talking about are like in the sea horizon down 4 or 5 feet, and if you're in a riverine system, you may have exposed that deeper layer, which is going to be mostly clay, due to erosional features of the river. So that's how we get to that level. Now, that's one way to do it, and there's methods. You can basically go back to the lab. You can actually take a soil sample and dry it out and measure the differences, different components of it, and get 3 parts, and you can figure it out in percentages and come up with it. That's a lot of work. There is a tailgate method where you basically can do this out in the field. The neat thing about it is that the silt precipitates out the sand precipitates out right away. The silt takes about 20 minutes, and the clay never precipitates out because it's so small, it just stays in the water column. But the good news is if you have the 2 parts, you can figure out the third, hence the concept of algebra. So at any rate, it is a way of doing that in the field. But again, you're talking half an hour to an hour before you really get an answer. There's another option, which is to use this chart, and I'll pull this one up. There's the chart, and this chart is what's known as a rub test, and we can actually rub the soil in the field. So I'm going to zoom in on the chart and continue this discussion. Okay, we've zoomed in, and to basically go over the texture, this is by feel. This is essentially the way you're going to rub the soil between your fingers.
And the idea basically is you do need a couple of teaspoons of soil roughly in your palm. And the difference with this, if you're used to using your muscle chart and you want to kind of preserve the color integrity, you don't have to worry about this. All you're going to be doing is trying to feel it. So you may need to add a little bit of water if it's very, very dry, so that you basically can break down, so it basically breaks down to the aggregates. If it's very clumpy, you want to break it down. It should feel like plastic, kind of like a putty. Okay, so that's really kind of our first step right here. Now, what we're going to do is we're going to start to ask you some questions. So once we've done that and it feels more or less, basically, the first question we have is, does the soil remain in a ball when squeezed? And that's the first question we ask. So we go through that, and then it's a yes or no. If it's a no, is the soil too dry? And you basically need to add more water. Okay, the idea is okay, fine. It's not too, you didn't add enough water is what it comes down to. So you kind of keep circling around until you basically get to the answer of this has to be, is the soil too dry? No. Is the soil too wet? Yes. Let it soak up. So basically the idea with these two questions is did you add too much water here, or didn't add enough? Once you have the right amount of water, you can finally get to the conclusion that basically if the soil does not remain in a ball when squeezed and the soil is not too dry and it's not too wet, it's sand. Congratulations, you've got sand. So that's an easy one. Now, we continue to go through the process. Now the next question is does the soil form a ribbon? And that's really the bottom line on it, is does it form a ribbon? Now, how long of a ribbon and all that we'll deal with next, but does it form a ribbon at all? And it's a yes or no. If it's a no, it's a loamy sand. You can't get it. It just crumbles as soon as you do that. It's not sand, but it's got a little bit of cohesiveness to it, but it basically breaks down right away, so it doesn't form a ribbon at all. I'll just scroll up here a little bit. Now, if it does form a ribbon, we then ask, how big is the ribbon? Is it less than an inch? Is it 1 to 2 inches? Or is it greater than 2 inches? So before it breaks off, and this is between your thumb and your forefinger, you're rolling it off. So if it makes a weak ribbon before it breaks, then we go down here and we add if we have to add a little bit more, we can rub with the forefinger, and then basically we ask a couple more questions. Is it very gritty? Yes, it's a loamy sand. If it's neither gritty nor smooth, kind of neutral, it's a loam. So you really don't feel the grit. It's a loam. If it's very smooth, kind of almost like baking flour, that's a silt loam, and you've got kind of that floury feel. If it forms a little bit of a ribbon, we go through the same questions: gritty, not gritty, or very smooth. If it's very gritty, it's a sandy clay loam. If it's neither gritty nor smooth, it's a clay loam. If it's very smooth, it's a silty clay loam. So essentially the same approach there. And then finally, if you've got a very long ribbon, we're primarily in the clays at this point. If it's gritty, it's got a little bit of sand in it, so we call it a sandy clay. If it's kind of neither gritty nor smooth, it's a clay, so it's got that kind of almost, it feels like, modeler's clay at that point. This is a pure clay. And then as it feels smooth, and that smooth is really coming from that kind of floury feel to it, and that is the silty clay. And that is the short version of how to do this by feel. It takes a lot of practice. There's contests on this, how to do this, but it is a great way to determine soil texture in the field and very quickly. If you would like a copy of this chart, we'd be happy to send it to you. We'll have some information on the YouTube link where you can get a copy of this, and we'll be happy to send it to you. It's just a little one-page thing. You can make a copy of it, stick it in your pocket, stick it in your muscle chart, and you're welcome to it. So with that, I will switch back over.
Okay, back to the bigger chart. Now, there's another option. I've heard farmers sticking it, between their cheek and gum. I'm not sure if they're thinking chewing tobacco or soil, but that's another method. You can rub it on your teeth. I wouldn't recommend any of those. Go with the chart. That's the best way to do it. Now, once we've established the component parts, sand, silt, and clay, we're then able to talk about the next layer of discussion, which is going to be whether it's an A soil, an S soil, or an F soil, and this is how the Corps organizes the types of hydric soil indicators associated with a wetland. Now, this is from USDA. The Corps basically will use the word borrowed this information from USDA. They get the gold star for figuring this out first, so they have a great resource for that. So at any rate, that wraps up this discussion for this week on hydric soil textures, or textures overall in soils. The one actually I will mention, we'll get into this next time when we talk about different indicators, but if it doesn't have sand, silt, or clay, in it, then you obviously don't have a texture in the traditional sense. Most of those fall into the category of what we call organic soils, where there's no mineral component to it. It's strictly an organic one, and we'll talk about that next time. But I just want to give you a heads up on that. That's a kind of a fourth category that we deal with in terms of texture, which is basically no texture. So with that, I wish you well. Hope to see you soon, and check out our website. We've got some great classes coming up this spring. We'd love to see you there, and have a great time, and we'll see you in the swamp.